Eddy currents are created whenever any piece of metal is adjacent to a moving or changing magnetic field. This simple demonstration has a box. Inside the box there is a coil, and the coil has a core which is iron, and it comes right the way up here. So we've extended the core right up to here, so we get the magnetic field outside of the box. And all I'm going to do is take this solid aluminium ring, put it over there, and I'm going to energize the coil. When I energize the coil, watch what happens. So this is operating at mains voltage. It doesn't matter, this can happen at any voltage. But if we go through the basics, when the coil is energized, a magnetic flux is produced up the iron core, which is hidden under this plastic trunking, and the magnetic flux is changing. It's going in and out 50 times a second. That's the frequency of the supply. So that changing flux passes over the aluminium ring. So we say the flux is cutting through the aluminium ring, and what happens then is, if the flux is cutting the aluminium ring, it will induce an EMF into the ring. If there is an EMF, it will have at some point a low potential and another point a high potential. A current will flow through the ring. It's going to flow around that ring. That current will then produce its own magnetic field, which is interacting with the first magnetic field coming up the iron core, producing a resultant force which lifts the iron ring. So eddy currents are travelling around the aluminium ring. I've left this on for probably half a minute or so now, and that was deliberate because right now that is very hot. Okay, that is hot. With the current travelling through it, it produces heat, and that is a waste of energy in many of our systems, for example in a motor or in a transformer. So that produces heat. How can we stop it? Well, the strategy is to try and stop the current circulating in the ring. And if I take this identical ring, identical except for one tiny thing, and that is that there is a saw cut in the ring. Not sure if you can catch that on the camera, but there is a tiny cut. That cut will stop the majority of the currents moving in that. So if I now energize the coil, there may well be an EMF induced into the aluminium ring, but it will be smaller, and the currents which we had flowing previously are no longer able to travel, and as a result this has no force exerted on it. Just to finally prove I'm not doing any tricks, if I put the solid one followed by the cut one, there is just enough energy, just enough work being done for the bottom ring to lift the cut ring. So in the real world, with items such as transformers, to try and prevent the circulating currents, we're going to use a laminated core. Here we can see that the laminations, the thin metal sheets, which are used on this tiny transformer, are cut into strips, and the purpose is to try and prevent large eddy currents from flowing as they would in a solid iron unit, a solid iron lump. So by breaking it up, we can reduce the eddy currents. Hopefully you can see. Okay, right, that'll do for now.